to HHBlits. So this is going to be a hidden Markov-based search of profiles, which is sequence plus structure plus conservation data. And it is super powerful because it takes all of the known groups of proteins, all of the protein families and things like that, crunches each one of those down to a profile. And so now instead of having to search through everything, it can only search through things that are actually understood and where we have decent data on what can vary, what never varies, stuff like that. So yeah, really good sequence annotation tool. HHBlits is going to need protein data. And if you try to paste in nucleotide data, here, let's try ACGT. It's going to say, hey, input contains nucleotide sequences. We're expecting protein sequences. Get your act together. So that's fine. We'll get rid of that. We'll paste in this. And now it says, that's protein. And it's not really in FASTA format, but it's not in FASTA format. So we can add a little title on here and say my sequence. There we go. And so now it says, okay, it's back. It's valid protein. It does not at least break the rules of FASTA format. You can only put in one of these, one protein at a time. This cannot handle multiples. And it also doesn't have any choice. You're going to look at the universal reference library, whether you like it or not. There is a hood. You can tinker around under it. That's the parameters tab. And so you can say, all right, how good a hit do I want for it to be included? How many hits do I want it to show me? Top 200, 5,000, whatever. More hits you select, I think, the longer it takes. How many iterations do you want to run? So we could take that and then we could essentially loop it and take all of our hits and see, are those still good hits? You know, adjust it, keep moving. And minimum probability. Probability is one of the values it collects or calculates in the hit list. And so you can set that at different numbers if you want really close things, really far things, or whatever. And so, bam, you would hit submit. Now, I'm not going to hit submit because I already have that job done. So here we go. This is the version of the job that's done. I just click to a new tab, and you'll see a lot of different things here. So at the top, you got a little slider. The slider will select part of the sequence. So let's say I believe these parts, but I want to take another look at this. And you can hit resubmit section, and it will go and resubmit everything from 1 to 1939 of my sequence. So it looks like my sequence is 2682 amino acids long. So there we go. Or whatever. You could just pick this part and kind of zoom in on that, focus on that, get rid of all this out here, and rerun the prediction just with this. These are the hits. The hits are color-coded, kind of the same way that blast hits are color-coded. So hot colors like red are good. Green is pretty iffy. Blue is almost always incorrect. And they do give you black hits, and those are usually not good. But that's just when it cannot find any meaningful way to say anything else about a particular sequence. So there you go. All right, down here, so you can click on these. Sometimes that's a little hard depending on the screen sizing, but if you click it, it'll take you down there. Sometimes it takes a minute if it has to load some things in. And this is an HHBlits result. So at the top, you will have, see the Q? That's your query. That's the thing that you put in. So that's your protein sequence. At the bottom, it'll have the thing that it's matching to. And so, bam, there's that thing. Like, okay, looking great. Let's see, what else have we got? We'll have whether or not it's a good match. And so a bar means an exact match. So Y on the top, Y on the bottom. Pluses are fairly close. So like D to an E, for example, yeah, that would be a plus. Dots are a little farther away, as are minuses, and then it'll just put nothing there if there's really nothing that it can say that is actually related there. So there you go. And generally you want to look for a more cluttered version of the middle with more little bars in it. Inside of this, there will be little guides that can take you through what each of those little symbols mean. So there you go. That's your stuff. Your input was back here. You can play with your parameters. Those are your results. The raw output, if you ever wanted to look at it, so this is a series of probabilities of matching to a particular thing, and which hidden Markov model it was that actually did the matching. You can plot the E values for this. You got a few that are real good down here, and then a bunch that are pretty terrible. And so based on this, you can say, okay, for my hit, if mine has a particular E value, like what are the chances that could occur? This is used for, I believe, calculating the percentage likelihood. Multiple sequence alignment. So this is the multiple sequence alignment that it made between your thing and all the other things it was comparing it to. So that's kind of neat. These are shown in FASTA format. They are not aligned to each other, but it is very easy to take this and then show them as being aligned to each other using different software. And yeah, here again, that's an alignment. So the template, these are the things that it sent back, or rather, and the query MSA, this is the multiple sequence alignment that it calculated while it was actually running. So there you go. But the main thing that you're going to need is going to be on the results page, and the numbers you're going to want are going to be, here we go, probability. That's an internal number from HHBlits only. But in general, your probability is going to be above 50% if it's any good. I like the E value better. So if we have an E value of 0.05 or less, so this is 1.6 times 10 to the minus 7, I like those odds. And this is showing you aligned columns. This is like how much of it they were able to align. It's similar to the query coverage number from BLAST. And the target length, this is the full size of the thing that you were trying to align to, which it turns out is rather big. So there you go. And I think that is all you need to know. So there we go.